Hello guys, our project was to design a low-costing airflow velocity measurement system. The group members involved is myself, Mert Tuncay-Utku Ağca, and Fatih Karabulut. Our supervisor for our project was Kerem Pekkan. One of the devices used to measure the flow velocity is the Pitot Tube. Pitot tubes are especially used to measure the speed of air transport vehicles. Here you can see a zoomed-in version of one of the Pitot tubes on an airplane. Although Pitot tubes are simple in terms of working principles, their production is quite costly. In this project, we have designed and produced a low-costing Pitot tube. The most important objective for this project is that it needs to be low costing and it needs to be precise enough that the design can be used in the industry without the need for another, more precise Pitot tube design. Our assumptions for the design are the following. Flow is steady, therefore flow rate and the velocity of the flow is steady.
In this project, we use Siemens NX to design it. In this slide, you can see our assumed CAD design. For this design, one of the critical points is the length of the incurved part of the right U-tube should be up to the middle of the other entrance of the U-pipe, because we want to measure velocity at the same location. Here, there are Pitot tube design and main pipe design. As you can see, we produced our part mostly with using 3D printer. We just purchased U-tube that is made of thin glass and purchased acetone as a liquid. We choose acetone as a liquid because it has low density and we could easily purchase and there is no harm for us. You can see the sum of the 3D printed parts. These two animations shows us what is going on inside our tube. The U-pipe records the difference in the pressure while we can record the delta H value from the U-pipe itself. It is important to note that the values shown are not precisely or values for experiment. You can see the animation. For testing, we used hairdryer as a flow generator and acetone as a liquid. You can see the fluid moving up and down as we turn the hairdryer on and off. You can see that liquid has blue color because we dripped the blue ink to paint it. Also, we covered the right arm with a white paper for a reason. Utku will explain what is the reason for this.
While writing the code of image processing, we took the dimensions of the black piece next to the pipe as a basis. The main logic in the code is to measure the length of the rectangular shapes by contour difference. There are three situations to be aware of. First, the figure to be measured is on light color surface. Second, the camera sees the shape which we want to measure clearly. Third, the color of the object should be dark and does not glare. While we were measuring the height difference here, we closed one arm of the pipe and dropped the blue ink on acetone to prevent reflection. When taking the height difference on the arm, the first took the height difference when the hairdryer was not working and then multiplied the height difference when the hairdryer was running by 2. We have assumed that flow is steady so that we can get the results from the height differences on the manometers. The longer L-shaped tube measures the total pressure, other one measures the static pressure. Difference between them gives the dynamic pressure. Therefore, we can get the velocity of the flow by the dynamic pressure.
In our researches, we found that in average hairdryer systems give an airflow velocity of 20 meters per second. Due to the pandemic, calculating the real airflow of our hairdryer was not possible. So from averages found from the internet, a 2500 watts air dryer blows at an approximately 20 meter per second velocity. With our calculations, we have found that our hair dryer blows at 17.36 meters per second. This puts our design efficiency around 86.75%. This design in the future can be implemented as a low-costing version. Of the Pitot Tube, the design is not precise enough to be used on airplanes that can reveal big ethical concerns, but it can be implemented into the industry with projects with low budgets. We give special thanks to our TAs, Puya and Berke, to our former TA, Reza, and to the machine shop technician, Muzaffer abi.